Determine the x and y intercepts of the linear relation y equals negative 2x minus 5. We know that when the line crosses the y-axis, that the value for x is 0. So that for the y-intercept, we know that x equals 0. So we can write our equation, y equals negative 2x minus 5, and substitute the value of 0 in for x, and we simplify. Negative 2 times 0 is 0, and so we have that y is equal to negative 5. We also know that by looking at the equation, the minus 5 is the y-intercept, and so in the past we've written that b is equal to negative 5. Similarly, for the x-intercept, we know that y is equal to 0. So we can again write our equation, y equals negative 2x minus 5, and this time we'll substitute 0 in for y. And now we have to solve our equation for x. So we need to isolate the x term, and so I will start by adding 5. 0 plus 5 is equal to negative 2x minus 5 plus 5. And we can see that minus 5 plus 5 is equal to 0. So we will now have 5 is equal to negative 2x. And to solve for 1x, I'm going to divide both sides of the equation by negative 2. And I will have that 1x is equal to negative 5 halves. So the x-intercept is negative 5 halves. The next thing we will do is we will go to Desmos, and we will graph the x and y intercepts as points on the grid. So we know that our y-intercept can be represented as the ordered pair 0, negative 5, which will be located down here on the y-axis, and our x-intercept can be represented as the ordered pair negative 5 halves 0, which is also the same as negative 2.5 0. So here's 3, and so negative 5 halves will be right there. We are also going to write include the equation y equals negative 2x minus 5. And if the line passes through the 2 points that we've calculated, then we know we have done our calculations correctly. And so when we put this information into Desmos, we end up with a graph that looks like this. And so here, the line crosses the y-axis, and there we see our y-intercept of negative 5. And at this point is where the line crosses the x-axis, and we can see that we have our x-intercept of negative 2.5. Our line, y equals negative 2x minus 5, passes through those 2 points, and so it gives us feedback that we have calculated both the y and the x-intercept correctly. Let's make a connection back to Activity 5 of Unit 1, where you looked at how the sign and position of the two intercepts affected the appearance of the linear relation. You notice that the linear relation is decreasing, or the slope is negative, when both intercepts are negative or when both intercepts are positive. And in this example, we do have both intercepts. And in this example, we have both intercepts negative. The y-intercept is negative 5. The x-intercept is negative 2.5. We see that the linear relation is decreasing as we move from left to right, and we see it in our equation where we see the slope is negative 2. As a reminder, the slope is defined as rise divided by run, or the change in vertical divided by the change in horizontal. And so if we started our y-intercept, we're going to rise 5 units, and then we will move left 2.5 units, which is a negative 2.5, and when we divide, we end up with a slope value of negative 2.